Imagine you are playing a game of pool, and you take a shot that sends the 8-ball toward the corner pocket. In our everyday world, once that ball starts moving, its path is set. But what if I told you that in the quantum world, the ball could actually reach the pocket and then, based on something you decide to do seconds later, actually change the path it took to get there? This sounds like pure science fiction, or maybe a glitch in the Matrix, but it is a real phenomenon known as the delayed choice quantum eraser experiment. This mind-bending setup suggests that what we do in the present might actually influence the history of the past. To understand this, we first have to look at the classic double-slit experiment. Usually, if you fire light particles or photons at two slits, they act like waves and create an interference pattern on a screen. But if you try to peek and see which slit a photon actually goes through, the universe gets shy. The moment you measure its path, it stops acting like a wave and starts acting like a tiny little pebble, hitting the screen in a boring straight line. This is the observer effect, where the act of looking changes the outcome. Physicists wondered if they could trick the universe. They asked what would happen if we gathered the information about which path the particle took, but didn't look at it until much later. This led to the creation of the quantum eraser. In this setup, scientists use special crystals to split a photon into two entangled twins. One twin goes to the main detector to record the pattern, while the other twin goes on a complex journey through a series of mirrors and sensors. Because they are entangled, whatever happens to one instantly affects the other, no matter the distance. Here is where it gets spooky. The experiment is designed so that the second photon's path can be revealed or completely erased. If the second photon hits a sensor that tells the scientists which path it took, the first photon on the main screen shows up as a simple particle. But if that path information is scrambled or erased using a clever arrangement of mirrors, the first photon suddenly behaves like a wave again. Here is the kicker that breaks our brains. The equipment is set up so that the second photon has a much longer path to travel. This means the first photon hits the screen and finishes its journey before the second photon even reaches the part of the experiment where its path information is either kept or erased. The first photon seems to know ahead of time what the scientists will choose to do with its twin later on. If the information is later erased, the photon acts like a wave in the past. If the information is kept, it acts like a particle. It is as if the present choice is traveling backward in time to rewrite the history of the photon's flight. This suggests that, at the quantum level, time might not be the straight arrow we think it is. It implies that information and causality are far more mysterious than we ever imagined. While we might not be able to send emails to our past selves yet, this experiment proves that the universe is way weirder than it looks. It challenges our fundamental understanding of reality itself. If you enjoyed this dive into the quantum rabbit hole, make sure to hit that like button and subscribe for more mind-blowing science. What do you think this means for the nature of time? Let me know in the comments below.